all over the world, scattered across continents and buried in time, stand the ancient temples of forgotten civilizations. Some carved from solid mountain faces, others built stone by stone in symmetrical perfection. They've stood for thousands of years, through earthquakes, storms, wars, and erosion. They tower over jungles, deserts, and hills, unfazed by the passing of ages. And here's what makes them even more astonishing. Many of these temples were constructed long before modern tools, machines, or even written records. The question echoes through time. How did they do it? How have these ancient temples managed to survive? And what lost techniques did their builders know that we may have forgotten? The answers aren't always found in dusty textbooks or modern engineering manuals. In many cases, the full methods used by ancient builders are still a mystery. But what we are learning from archaeology, engineering analysis, and material science is that these early civilizations understood more about building than we once gave them credit for. In fact, some of their methods may have even surpassed ours in durability. Let's start with the Great Temple of Karnak in Egypt. Dating back over 3,000 years, it was built by successive generations of pharaohs and remains one of the largest religious structures ever created. The columns soar skyward, each weighing over 100 tons. The stones were quarried miles away and somehow transported across desert and river, then lifted into place without cranes or forklifts. It wasn't just brute strength. These builders mastered balance, leverage, and an intuitive understanding of geometry and structural load. Then there's the Parthenon in Athens, built in the 5th century BCE. Even though it's partially ruined, it has withstood earthquakes and centuries of weather. Its columns aren't perfectly straight. They bulge slightly in the middle. This isn't an error. It's intentional. Ancient Greek architects used a technique called entasis, a subtle curvature that corrected optical illusions and added strength to the columns. They built with an understanding of both aesthetics and physics, something many modern engineers are only now beginning to appreciate in full. But some temples baffle even the experts. Take the Kailasa temple in Ellora, India. It wasn't built from the ground up. It was carved from the top down, out of a single massive rock. That's right. The entire structure, complete with columns, statues, inner chambers, and towering spires, was carved vertically into the earth from a mountain face. It's estimated that over 200,000 tons of rock were removed, with perfect symmetry and no room for error. If the workers made a mistake, they couldn't patch it. The whole temple would be ruined. No blueprints from the era remain. No documentation tells us how they managed this feat with only chisels, hammers, and rudimentary tools. Its construction as sculpture, engineering as an art form. And it still stands today, nearly 100 years later. One reason these temples endure is because of the materials used. Many were built with stone, granite, basalt, limestone, materials that, while hard to work with, are almost impervious to time. These stones don't rust, warp, or burn. But what's even more surprising is how precisely they were cut and fitted together. In some Incan and Egyptian temples, stones were cut so tightly that not even a razor blade can fit between them. No mortar, just perfectly interlocking blocks. How? One theory suggests ancient builders used primitive forms of vibration, sanding, or even unknown metal alloys to shape stones with incredible accuracy. In Peru, the walls of Sacsayhuaman use massive stones, some weighing more than 100 tons, fit together like a jigsaw puzzle. Each block is a unique shape, carved to match its neighbors precisely. This method not only created a stable wall, but one that could withstand earthquakes. The joints allow for a degree of movement without collapse, a concept similar to modern seismic engineering. Seismic resistance isn't unique to the Incas. In Japan, ancient wooden temples like the Horyuji Temple have stood for over 1,300 years. They were built with joinery techniques that allow the wood to flex during earthquakes. Instead of using nails, builders used wooden joints that can move and absorb shocks. These temples sway, but they don't fall. And this flexibility has allowed them to survive in one of the world's most earthquake-prone regions. In Cambodia, the Angkor Wat temple complex tells another story. Built in the 12th century, it covers more ground than any other religious monument on Earth. It's aligned with celestial bodies, filled with intricate carvings, and built with sandstone blocks transported over vast distances. Recent studies suggest the builders may have used a complex system of canals and rafts to float the stones to the site. It's not just architecture, it's logistics on a massive scale, and all without modern engines or machinery. So how did these ancient builders align their temples so precisely with stars, solstices, and lunar cycles? Many were astronomers, philosophers, and mathematicians as well as craftsmen. Structures like Stonehenge, the Mayan temples at Chichen Itza, or the Egyptian pyramids were aligned with incredible precision, often tracking the equinoxes, solstices, or even eclipses. These alignments weren't accidents. They were built into the DNA of the temple, and achieving them required not just tools, but deep, generational knowledge. But not all their secrets were carved in stone. In many cases, oral traditions passed down techniques that modern historians never recorded. Ancient builders may have used forgotten methods, like using heat and water to fracture rock, or even softening certain stones with plant-based chemical treatments. While evidence is limited, it's clear that many of their methods relied on an intimate, almost instinctive understanding of materials and environment. We also have to consider the human element. Many of these structures were built over generations, with workforces numbering in the tens of thousands. These weren't just laborers, they were skilled artisans who trained for years. Building a temple was a sacred act, not just a job. Pride, precision, and purpose were built into every block. As time passed, empires fell, languages changed, and knowledge was lost. The rise of modern construction focused on speed, cost, and scalability. We built higher and faster, but not always better. And while skyscrapers go up in months, many ancient temples took decades or even centuries to complete. They were built for eternity. Ironically, the durability of ancient temples may also be due to what they lack. They have no rebar to corrode, no concrete to crack, no insulation to decay. Their simplicity and the permanence of stone makes them immune to many of the failures of modern buildings. Today, engineers are turning back to the past for inspiration. Researchers study ancient joinery, mortarless construction, and stone balancing to find sustainable, earthquake-resistant solutions for modern buildings. What was once seen as primitive is now seen as advanced, just in a different way. So when we look at these ancient temples, we're not just admiring old buildings. We're seeing the legacy of lost knowledge. Engineering so advanced, it has survived the test of time better than some of our most sophisticated creations. Each stone, each joint, each alignment tells a story of people who understood the forces of nature, the movement of the earth, and the materials they worked with. Temples like these are time machines, inviting us to learn, to wonder, and to rediscover what we may have forgotten. Their endurance isn't just physical, it's symbolic. A reminder that brilliance doesn't only exist in the present. Sometimes, it's hidden in the shadows of history, waiting to be rediscovered. Thank you for watching. If you were amazed by the secrets behind these ancient marvels, give this video a like and share it with someone who loves history, architecture, or mystery. And don't forget to subscribe to the channel. There's so much more to uncover about the world's greatest feats of science, engineering, and human achievement. Until next time, keep exploring and never stop being curious.